Hello, today it's my pleasure to talk about using MATLAB in numerical methods. We're going to first talk about getting MATLAB installed on your computer. Then we're going to delve into the Integrated Development Environment, or the IDE. We're going to talk about defining variables, using your basic operators, relational operators, less than, equal to. We're going to talk about logical operators, and or. We're going to talk about the basic functions in MATLAB. Control flow. For control flow, this is the kind of thing like an if statement, a for loop, or a while loop. We're going to talk about defining our own functions. We're going to talk about variable scope, where we have a global variable, a persistent variable, or a local variable. We're going to talk about developing arrays. We're going to talk about structures, and finally, we're going to talk about scripts. So first of all, I recommend you pay the $119 and you get the actual student version of MATLAB. Yes, you could get the UF Apps version. There's also an open source version, but there's pitfalls for each of these other two options. For the student MATLAB version, you can go to this link that I've provided to you, and you can get the MATLAB and Simulink Student Suite. It's $119, so that's not a bad price for you. So I'd recommend doing that. There is a UF Apps option, but there's pitfalls. There's gotchas when you try to do this. Sometimes it is down and you're not able to do your work. There's also a GNU Octave option. This is an option that can work for a lot of MATLAB, but there are some inconsistencies with it. So I want to talk a little bit about the IDE background. First of all, I want to go through the File Explorer. I want to introduce you to Notepad++, and then we're going to delve into the actual MATLAB Integrated Development Environment, the IDE. So File Explorer, aren't you often frustrated with you can't find your files? Well, I've been using OneDrive, so I've drunk the juice, as they say, and I've been using OneDrive. And if you see up here, I've got OneDrive, I've got my University of Florida account, and I've created a directory for this course, and I'm working out of the Spring 2026 folder here. So that's where I'm going to put my stuff. So I encourage you to create your own directory for each course in your OneDrive, and then you can access it reliably. And inside that OneDrive EGM 3344, the Spring 2026, I've created a day one subfolder, and that's what I'm going to use for today. So you can see I've already got a function in there that I'm going to rely on today. So Notepad++, so this is a open source program that allows you to edit your source code. There's syntax highlighting. I really like it, so that's what I'll use when I work with you guys and trying to show you my code. So I encourage you to do that, and it keeps your MATLAB IDE from being overly cluttered. So here is the MATLAB IDE, and I'm going to show you what I focus on. First thing is I want to make sure I get my directory identified, and I think I click here, and then that brings up my directory, and I've got it selected as I showed you. My OneDrive, I've got the course, I've got the term, and then I'm in day one, and then you see that simple func there. And those, so whatever files I have in this directory is very, very focused, and I can reliably find my files, and that's the functions I'll be using if I were to type them into the prompt. So that's the second most important thing. And then the third one is all your workspace, and this, of course, is where your variables are. One thing I don't really mess around with are up these bells and whistles up here. I don't mess around with that. I use the command window. I use the command window. This is where I type my command. So I want a nice, big, healthy spot to do that. And putting everything together for the IDE, as far as I know, I focus on the directory. As I was saying, I can see the files that are in the directory right there. Those are the files I can use from the command window. I've got the workspace, so I can see what kind of variables I have in my workspace at my disposal within the command window. So let's go do some things in MATLAB. All right, are you ready to do some MATLABing? Let's see what we can do. I've already entered in a variable here, x, so if I type in x, I can see that I had already assigned it the value of 5. Let's go ahead and give myself a y, maybe 6. And if I do the y equals 6 like that, it'll actually print it. But if I don't want to print, I could just do y equals 6 with a semicolon. And I could do I could reassign the x as 5. And over here you can see I've got those variables in my workspace. So now I could do, something like an x plus y. See what that value is, x times y. See what that value is. I can do an x minus y. Whoops. So here's one where I typed it in wrong. So you can see that MATLAB gives you a nice error message there. So try to respond to that and figure out what you did wrong. So that's an easy one. So I got that. If I want to do x divided by y, I got that. So that's 5, 6. So those are your basic operators. If I want to do exponentiation, 5 squared is 25, and 6 squared is 36. So those are your basic arithmetic operators. If I want to do something like a relational operator, I can say, well, 5 is less than 6 for sure. Actually, let me clear my command window, CLC, clear my command window. Now I've kind of freshened up. So I can do x is less than y. And that's actually going to provide a logical or like a Boolean result, logical 1. So that means that's a true. It's logical 1. So I can do x greater than y. So 5 is not greater than 6. So that should be a logical 0 or a false. So as you can see that these are relational operators that give you a logical result. CLC. I can do x is less than or equal to y. I can do that. X, and I guess x is greater than or equal to y. That should be false. Okay, so those are some relationals. Now, what if I did x? I want to know if x is equal to y. It's not. X is not equal. It's a tilde equal y. That should be true. So those are your relational operators. What if I did something like this? I'm going to clear command. All right, what if I did something like this? I want to see if x is equal to y, which is 6, minus 1. So that 6 minus 1 is 5. X is 5, so that should be a true, right? I think so. Yes, it is a true. Okay, so now let me go do something really weird. I'm going to say z. I'm going to give myself another variable z. And I'm going to say that's equal to 5 times, I'm going to go 1 minus 3 times, let's see, I'm going to go with something crazy. 4 divided by 3 minus 1, something like that, plus 5. So I've got, let me just make sure I get this right. So I've got 4/3 minus 1, so that should be 1/3, times 3 should be a 1. 3 times the 1/3 is 1. So I have 1 minus 1, that should be 0. 0 times 5 is 0. I add 5. Z should be 5. Don't you agree? Let's see what it is. Yeah. So now, what if I did, and then x is 5, right? What if I did, I want to do a test. X is equal to Z. So x is equal to Z. So Z is 5, X is 5. Let's see what happens. It gives me a logical 0. So here we go. Our first numerical methods revelation here is things can get kind of tricky when you are looking at combining numbers together, and you might not get what you think you're going to get. That 5 for the Z is not actually equal to exactly 5. It's not an integer 5. It is a floating point 5, and it's got some, I call it fuzz on it. And what you could do is instead, if you want to find out if they're really, really close, what you could do is you could do an absolute value of x minus z and see what that gives you. And you could see that you're getting something 10 to the minus 16th. So it's very, very small, but it is not equal to 0. And that's kind of your fuzz. And what you could do is you could say, you could take that, I'm going to go up arrow so I get that same thing again. And you could test whether that is less than or equal to some very, very small number. And that's going to be true. Okay, so that's how you would sort of test that. So that's our relational operators, and I gave you some really good background, especially with that type of thing right there, that would show you how you need to test whether two floating point values are equal. You actually have to do an absolute values, the absolute value function, and you operate on the difference, and you see if that's less than some very, very minute tolerance. So I'm going to clear command here. So those are relational operators, and there's also some logical operators, and those kind of look like this. So if I do, let me just make something up here. What if I did 1 equals 1? That's a true. So let me go 1 equals 1 and 2 equals 2. So that should be true and true, which is true. So what if I did the same thing? So that's logical and. What if I did a logical or? Well, they're both true, so true or true. The result should be true. But what if I did something like this, where I did 2 equals 3? So the second one is false, but the first one is true, so I have true or false, so that should be true. And what if I did something like 1 I'm testing is 1 equal to 2, so that's false. False or false, that should be false, and it is. So let me clear command here. So I think that took care of a couple of things. So you kind of get the idea here. So if I do the ands now, that should be a false. 1 equals 2 is false, and 2 equals 3 is false. So that should be false and false. That should be a 0, right? So let me go make this a 3. 3 equals 3, so the right-hand one's true, but the left one's false. So false and true is going to be a false. But let me go change this one now to 2 equals 2. So now they're both going to be, that's true and true. So that the combination of those should be true, and they are. So that is the logical operators, the and the or. The only other one that I wanted to show you is called the not, and I'm going to go and put a tilde in front of all this. So that would basically, whatever is inside the parens, that tilde will make it logical opposite. So what's in the parens we just saw was true, so this should make the result false, and it does. So the and, the or operator that I showed you earlier, and then the tilde. So those are your three logical operators. Clear command here, clear command window. So I've shown you already an absolute value function, right, where we did z minus x and got that very, very small. But of course, the abs function will work on anything. So if I obviously absolute of 1 is going to be 1. But if I had a negative value, it would be 1. So it's going to be absolute value. So abs is our first function that we've looked at. Clear command. In MATLAB, it has a built-in pi. So I could look at another function, maybe the cosine of pi divided by 4, which should be square root of 2 over 2, which it is. Well, let's see. See if that's equal to the square root. There's another function of 2 divided by 2. We'll see if that works out, and it did. The best way, again, is to check what the difference is here, and there may be some fuzz. Let's see. Don't think there is. If it gave us a logical true, it would have to, there's no fuzz there like there was for the other one. So their absolute is perfectly 0. So that's the only way you get that logical 1 there, is in they actually perfectly are equal. So there's some functions for you. Clear command. If I want to clear the workspace, I go clear. So that clears my workspace. All right, and then if I want to set x equal to 5 and y equal to 6, I can get those back in. Now what I want to do is show you a help function. So I could go help abs and whatever, and it'll give you this. I use this all the time. See what the heck a various function might be, right? So those are built-in functions right there. Helps abs, clear command. I could go help cosine that I had earlier. So that's the cosine of the value. All right. And then clear command, not clear workspace. So I still have my x and my y. So now I've got this simple func here that I've written. I'll show you in a minute what it is. But I'm going to go help there. Help. So it's going to look at simple func. See what's there. So it's printing 2 lines here. So, and I want to show you in a minute where those 2 lines are coming from. But it's printing out what this simple func will do. It's simply just adding. You're going to give it 2 arguments, an a and a b. It's just simply adding those together and returning it. So it's kind of a very contrived, simplistic function. So I'm going to go simple func. X and y. So that's 5 plus 6, so it should be 11, and that's what it is. Okay, so if you take a look at what we've done so far, we've talked about getting MATLAB. We've looked at our IDE, little survey of it. We did some variable stuff, operators, all kinds of operators, relational, logical. We started looking at some functions. So the next thing is to take a look at our control flow. So let's do that now. All right, let's take a look at a first thing is an if statement. So if x is 5, if x is less than y, 5 and y is 6, so 5 is less than 6, that's going to be true. So I want to display path 1, okay, and then I'm going to go else display path 2. Okay, and then notice that MATLAB doesn't give us the prompt, so it sees that if, and it's sort of waiting for the end to come. All right, so let's see what happens here. So I did an if x is less than y, which we know is true. It should run this display function and show path 1, and that's what happens. So it has done this. It has run the display function. That's a very simple debug function for you, and it's just printed that string path 1, and that's it. So I could get it to do the else if I said if x is greater than y, which we know is false, display path 1 is, it's not going to do that. It's going to do the else end. All right, so now as soon as when I hit the end, it's going to run that, and it is path 2. So that is how that works. The if statement, it's a control statement. Now what I could do, I don't need the else. Let's say if 1 equals 1, display path 1 end. I don't have to have the else, and that was true. All right, well, what if 1 equals 2, which we know is false, display, can't spell display path 1 and end, and then nothing should happen now because, well, 1's not equal to 2, so nothing happens. It just gives me the prompt back. So you don't have to have the else. Now, let's say I wanted to have a little more specificity here and more options. Let me do, I'm going to clear command. What if I said if x is greater than y, which we know is false, in this case, display path 1, else if, now look at there, it's helping me type it in, else if x is less than y, display path 2, and I could put an else. I don't have to have this final else, but I'll go ahead and put it path 3 end. So x is less than y because x is 5 and y is 6. So I should be in this bracket right here, in this else, that middle one. So let's see what happens. Path 2, that's true. Let me see. I'm going to see if I can copy that. Copy, paste, good. So I'm going to come in here and I'm going to say if x equals y. So for this, x is not greater than, x is 5 and y is 6, so this is not going to be true. X is 5 and y is 6, so this is not going to be true. So it should drill down to that final path. It should go path 3 here when it displays, and it does. So that's a control, some control logic using the if statement. Okay. Now for a while statement, I want to do this. I want to say, I want to create like an integer, something like an I equals 1. So I'm going to go with a semicolon, says doesn't print. And then I can say while I is less than 5, I want to display I, end. Okay, but it's going to be an infinite loop it's going to be an if, because I'm going to have to do a semicolon. I need to go back up here and do a semicolon. It's not letting me do it. I don't know. Let's see. I equals I plus 1, and then end. Let's see if this works. That semicolon should be up here. It's not letting me go back. But let me see if this works. It did. So so every time through this loop, I increments. So I'm going to do it a little prettier this time. Copy. Well, I'll just type it in. While I is less than 10. Let's do that. So I right now is actually 5. So I can get it to go a little bit further. And then I equals I plus 1. Yeah, I was a little upset I didn't have that semicolon up there to finish that end of that line. So now this is a little bit better looking. Okay, so it continued with the I as it was from that previous, because it's in the workspace. It just added I, displayed it, and then it added I. And that last time through, I became 10. And then as it followed through the loop again, it broke out of the loop. Okay, so that is a while loop. Very simple, very straightforward. The last one I wanted to show you is a for loop. And I actually use for loops more than I do while loops. But before I can do that, I've got to kind of give you a sneak peek of an array. So if I type in 1:5, that's going to give me a row vector of 1, 2, 3, 4, 5. And I can use that in a for loop. I can say for I equals 1 to 5. I can display I and end. So that will display each line the current value of I, starting at 1 and finishing at 5. Let's see what happens. 1, 2, 3, 4, 5. It's just it's run that for loop 5 times because I had 1 to 5. So those are your control keywords, I guess is the word. The correct word to use is a keyword. If, while, and for. Those are very, very powerful. Okay, so far you might be very familiar with the things I've talked about, and I'd like to kind of pick the pace up a little bit, maybe give you some new way of looking at how to write functions, and I want to talk a little bit about variable scope, and I want to introduce some ideas about debugging. These things I'm going to talk about right now are really going to elevate the ability you have in doing numerical methods. So let's, before we do our own functions, let's remember our quadratic equation. So we've got a polynomial, ax squared plus bx plus c equals 0. Let's say that we're given the coefficients a, b, and c, and we want to solve for the two x values that will satisfy that equation. It's well known that x1 is minus b plus or minus the square root of b squared minus 4ac divided by 2a. So the discriminant is b squared minus 4ac. So very well known. It's basically the same thing. It's just that in one of the x's gets the plus on the radical and the other x gets the minus. So very straightforward. Okay, let's return back to our MATLAB workspace where I've cleared it. I've reset my x to 5 and my y to 6. And remember, when I ran the simple func with x and y as the inputs, it returned 11 because the simple func is simply just adding those values together. Where does this come from? Okay, let's bring up the simple func. I could open it there, or I could go into my file explorer and bring that up. And then I want to show you now editing with the notepad. It's really kind of easy to do. So I've got my function is pulled up, my simple func. So I type this in. It's a text file, very straightforward. So you go function z equals simple func a comma b. So this whatever is here needs to be the name of the file .m. Okay, so that's one thing. And then the percent symbol here signifies a comment, and whatever comes after that is a comment. The whole line, basically, if that's all that's on it. So these first lines, that is what is returned. So what I do is I will repeat whatever is here. I'll just repeat it, and then I'll add some specifics about what the function does. So this gives help, and it's documenting my code, very straightforward here. And then this is the actual function. This is the actual statement that constitutes what the function does. Just simply adds A and B. Now, all right, so you ready for this? I'm going to add another comment, and I'm going to say A, B, and Z are local variables. So if you ever hear the term local variable, they're local to this function. They only show in this function. You don't see them over here in the workspace. They are local to that function. The workspace, if I type A, B, or Z over here, I get nothing. It'll give me an error. Like if I type Z, it gives me an error. A gives me an error. So those are local variables. They only have meaning inside this function. Okay, so I think that's very important. I'm going to save that. And what I want to do is I'm going to save this function file just as this, very easy. Just take this, do a file, save as, and I'm going to create another function. I'm going to call it quad func .m. See if I can do that. All right, so quad func.m. I see it over here, quad func.m. I see it. I got quad func.m. Now, to get this to be actually be a function, I need to do that quad func. Now, you ready for this? I'm going to make this my quadratic function that's going to return the two x's. Okay, so I'm going to go xx, and then I'm going to go quad func ABC, ABC, and xx are local variables, and it's solving for x1 and x2 such that a x1 squared plus b x1 plus c equals 0. Okay. And I'll just put and x2 such that. All right. And then we're going to return equals. Now this is an array. I'm going to return x1 and x2. I'm going to return as a row vector the two x's that satisfy it. Okay, so I've got to do that. So I'm going to go, you know what? I think I might even do like a radical here. I might even give myself the radical piece. I'm going to R1 is the square root of the discriminant. Okay, so I'm going to go R1 equals, that's a local variable. It's also a local variable. X1, X2, R1 are local variables. So, so I'm going to go square root of B squared minus 4 times A times C. So that's my radical. Then I'm going to go X1 equals minus B plus R1 divided by 2 times A. Trying to have some discipline here with my dividing with my parens, my division, and then I can say XX equals the array. So array starts with a square bracket, and then I do X1 comma, so the comma makes it go like it's on the same row. All right, so I think this will work. Okay, so just checking it out again. I got that is the same name as the file. My comments make sense. Comment name is the same as the function name. I've got function, I've got end. Nothing funky going on here, I don't think. I save it. Okay. And let me do clear command. So I think I'm ready to try it. So I'm going to try quad func of A. Let me go. A was 1, B is 3, C is 2. Let's see what I get. Okay, so there's my two answers. So X1 is minus 1 and X2 is minus 2. I could do something like this. I could go A equals 1, B equals 3, C equals 2, right? And then I could say XX equals quad func A, B, C. Right there, right? So XX is, as we know. So here I could check it. I could say A times XX. And if I want to index, I go with the parens. So when A, XX, that would be X1 squared plus B times XX. This would be the X1. I'm indexing into that XX row vector plus C. Let's see what this does. So 0. Okay. So then I can just do an up arrow and check my other one very quickly. Right? Or I could say 4I equals 1 to 2. I could go display A XXI squared plus B times XXI. Let's see what this does. I'm having fun now, making it up as I go. See what kind of, whoop, what happened? Oh, okay. Didn't have that closing paren, so I think I have to do the whole thing again. No biggie, no biggie. Yeah, so it told me what I did wrong. I want to display A times XX. Do you notice all this help that's kind of flashing around? That's very distracting. So when I write my script, I want you to see how this stuff kind of goes away when you're writing your script within Notepad. I just want to make sure you understand that. That's one of the reasons I do it. All right, so I is going to be 1 and it's going to be 2. So I'm basically going to index and check both you doing this. It's going to be that this for loop will run once for I equal 1 and a second time for I equal 2, and they're both 0. Okay, isn't that cool? Okay, so right, so that is as how we've written our first function, there. Now what I'd like to show you, so we've done local variables for sure. Now what I'd like to show you is something called a global variable. So I'm going to clear command, and I'm going to define a global variable. And I'm going to call it, I'm going to go all caps on the variable name. I'm going to call it debug. MWG, my initials, and I'm going to call it MWG debug, and I've got an underscore there just to kind of make it look like two words. So that's how you declare a global variable. And then I'm going to go MWG debug equals true. So I want to debug. I want to turn on the ability to debug and to print. All right, so I've got that. So here's what I'm going to do is I'm going to take that function that I defined for you guys, and I'm going to save as, I'm going to save it as a quad func D. So underscore D means debug, just for the context here, .m. Okay, so I've got that, and now I need to make sure that and you see it just popped up over here. So now I need to go and add that underscore D, add that underscore D. So this is the debug version. I could add a comment. Okay. In the debug version, what I could do is I've also got to bring this in. I've got to say global MWG debug, and it's going to bring it in. And then I could say if, because otherwise, whatever variable I define over here, like I had, the x's and the y's earlier, whatever variable I had defined out here, it's not seeable in here. So that's why I have to do the MWG, or the global, if MWG, see if this works. And then I want to end. Well, I want to print something, but I've put my if debug too early. I want to print out my R1 here. Right? I want to print out my X1 here. Maybe just some internal. I think this is how I do it. My X2. So it's going to give me a little character string ahead of the actual value that's going to be displayed. I think this will work. Save it. Just double check. I got my name, same function, got the comment. This is the debug version. All right, I got my calculations, and then I'm going to debug if I want to. I could turn it on, turn it off. And right now it's turned on. So I think this works. So now I go quad func D for debug, 1, 3, 2. And there they are. So this right here comes about from me having the debug on, and inside the function, these are being printed out, and then it provides the answer again. So I think I can turn MWG bug equals false and rerun, and it just gives me the answer, and it doesn't give me the debug. So that is the global aspect. So that's how you can use a global variable to control whether you're debugging within your function. Okay, so that's another example of a different kind of variable scope, and that actually allows you to debug. Okay, so another one I'd like to show you is called a persistent variable. And for that, to do that, I'm going to save as a D. I'll just make it debug with persistent. So I've got an underscore P there, right? You see it popped up over here. Okay, so I've got persistent, and I'll put is the persistent version 2. So what that means is I'm going to have a persistent, and I'm going to call it a variable. I'm going to call it K. Okay, and now I'll have to initialize the persistent variable, and this is quite frankly a little bit ugly, but it's no big deal. I'll go if K is not defined yet, I'm going to say if is empty, I think is the correct thing. If it's empty, I'm going to set K equal to 1. So K is going to be a persistent counter. So I'll tell you what it is. K is a persistent counter. Each time, each call, K increments. Okay, so the first time through, K is 1. Every time through, K equals K plus 1. You know what? Actually, I think I want to initialize it to be 0. So the first time through, K will be 1, and then here I'm going to display K. Plus K there. So it's going to glue that. It's going to glue the value of K onto that string, and it should print out a pretty K every time I call it. All right, just double checking. So I got the D for debug. I got the P for persistent. Debug, persistent. I'm going to make that a P. There, so DP, DP, DP. All right, so I think that's all good. So I save it, and if I were to say help quad func DP, so it gives me all of that. Okay, and what I like to do is to turn my debug back on. Okay, clear command. Debug's on. Now I'm going to go quad func DP 1, 3, 2. And you see it the first time through, K is 1. There comes a time, there are instances where you want to know the number of times your function's been called. So there are good instances for that. So if I call it again, K increments to 2. So it saves it as persistent. Every time quad func DP is called, K gets incremented and it saves the previous value. So that's how persistent works. Okay, hopefully you've gained an appreciation for functions. You've gained some new viewpoints on that. You've gained some new viewpoints on different kinds of variable scopes. You've learned what local variables are. You've learned what global ones are. You use that to turn on and off debugging. And there's also this notion of a persistent variable. Okay, so we're almost done. We're going to talk about arrays. We're going to talk about structures, and then we're going to talk about scripts. Okay, I've kind of given you some examples of arrays already. We talked about a row vector. I'm going to call row vector R1, a row 1, and I'm going to set that equal to, let's say, 10, comma, 11, comma, 12. Okay, so the braces, the square braces give you that array, and then the commas make it grow column by column. And let's see what that returns. So yeah, it's a row vector. So if I go call one, column vector, now for that, I use the square brackets, but I'm going to call this 20, and then you use semicolons, 21 and 22. Okay, so that's going to be, should be a 3-element. Oh, I put the semicolon at the end. Let's see, call one. Okay, so call one is 20, 21, and 22. And you see that I've got them in my workspace. I'm going to create a matrix mat1, and I'm going to call that as 1, 2, 3, first row. I end the row with a semicolon, and then I'll go 4 minus 5, 6 in the second row with a semicolon, and then I'll go 7, 8, and 9. Okay. Square brackets, and I want to see it, so I don't put a semicolon. So there's my 3x3 array matrix, 3 rows and 3 columns. So you see it very nicely right there. Now, if I want to index in, I use the paren. So if I want the second element of row 1, I call it out like that, and that should be 11. If I want the second, or maybe the third element of call 3, I should get 22. Yep. And if I want, say, in mat1, if I want the second row, third, you see all this helping stuff here? It's just very distracting. Mat1, 2, comma 3. So that should bring out 6. That should be 6. Second row, third column, and that's 6. Okay, so if I were to come over here, I see my various entries here, and I look at this, and it shows up in a very nice format there. It shows it as a 3x3 double. And you remember we still had the x equals 5 thing, right? So I want to show you, before I forget, I'm going to show you the size function. So if I go size of x, it shows it as a 1 by 1. So interestingly, everything's a matrix in MATLAB. So x is a 1 by 1. It's just a scalar 5, but it shows it as a 1 by 1 matrix. And if I go size of row 1, it shows it as a 1 row by 3 columns. If I go size of call 1, that should be a 3 row in 1 column. And if I go size of mat1, that should be 3 rows and 3 columns, right? Okay, so that's how you define arrays, row, column, or just a two-dimensional matrix. That's how you index into the arrays. Okay, now this is how you check the size. Now if I want like the whole second row of the matrix, I go whole second row, I go 2, and then I go comma, colon. So the colon tells me I want them all, right? So I'm going to go row 2, all of them. And that's going to be 4 minus 5 and 6. If I want the third column, say, I go all rows, third column. Okay, so the colon means all rows, third column. It brings it back as a column. Okay, so that's how you create arrays. That's how you index into them. That's how you pull things out of the array. Another thing I could show you is concatenation. So I could say square bracket mat1, and if I go comma, that's going to add more columns. So I could go call 1. I think I can do this. So that's going to take the matrix as a 3 by 3, and it's going to append a fourth column on that. And it did. Okay, so that looks good. Now, if I wanted to append a fourth row to mat, then I go, I use the this is concatenation. I do it like this. Okay, and that's it. So that takes care of the handling of matrices quite nicely. So from time to time, we want to take and combine things that are disparate. They're different kinds of things. Like I could create a structure. I'm just going to call it SS. And I'm going to create that structure, and I'm going to say ss.r1. Now I could go row 1, but I just want to call it a different variable. So I'm going to call it ss.r1, and I want that to be row 1. Let's see if this works. Yeah, so that's going to be a structure. And I'm going to go ss.c1, so that's going to be my call 1. Okay. And then I'm going to go ss.mat, or m1. I'm going to call it m1 just to be a little consistent. So I've got a structure that has 3 elements. It's got a row vector, it's got a column vector, and then it's got the 2D vector. And what would it look like? So here it is, SS. Let's see what that looks like up here. All right, so it's a 1-by-1 structure with 3 fields. It's got a row, R1. It's got a C1, and it's got an M1. Okay, so structures are good for kind of combining things that are disparate. They're different things, and given a coherent collection of things that are disparate, that's when you use a structure. And it takes a little getting used to, but they're very, very powerful, and it creates a good basis for an algorithm when you can keep things kind of collected together. Okay, we're almost done. We've checked out our arrays. We've introduced structures. Now the last thing I want to do is I want to write one more function, and then I want to call it from a script, and then we'll be done. Okay, I want to take the original quad func here, and I'm going to do something funky, and I'm going to save it as a quad func S, so that I could have a struct version of this. So I got quad func S, put underscore S, underscore S. This is the struct version, and I want to create a check variable. All right, so I'm going to check check1 equals a times x1 squared plus b times x1 plus c. So I want that. I have a check1 local variable. I have a check2, and I'm checking the value of my second x. And then I want to send back an array of my 2 checks. All right, so I've got 2 arrays, and put some more comments up here. The check of x1 check 2 is the check of x2. All right, and then I'm up here, I'm just going to add local variables. All right, just tell them those are local variables. And I'm going to return a struct SS, which is a local variable. It's not going to be in the global domain. So I could say down here, my very last thing is SS dot XX equals XX, and SS dot CK equals CK. Okay, so that should work. Checking it. Got the name, 3 places is correct. That changes to SS. SS is a struct. Struct of XX and CK. Okay, so I save that. I think I'm good. And the function shows up here. So I'm going to go quad func S of 1, 3, 2. See what happens. All right, structs with the fields, -1, -2 for my x1, x2, and then my 2 checks seem to check out as being 0. Okay, so let's see if we can write a script that will call the quad func S a number of times and then print the results. So to do that, I'm going to come up here and I'm going to say new file, save as. I'm in day 1. I love it. I love it. So I want to make sure it's going to be, I'm going to call it script1.m. All right, so so I'm going to go clear command, clear workspace, start all fresh. A equals 1, B equals 3, C equals 2, right? And then I'm going to go for I equals 1 to 10. I'm going to go, so you're supposed to indent. So SS equals quad func S A, B, C, like that. You know, to be honest, I might just display something like a flag here, some kind of header. All right, so I'm going to display a header. I'm calling my func. After my func, I'm going to have the struct that is going to contain the 2 X values and then the checks. So I could display I like that, just what I iteration I'm on. And then I could display X1, just make it where they kind of look nice. All right, and then I think I want to, well, it's not X1. It's not X1, right? It's going to be SS dot XX1, right? That's what it's going to be, because I'm returning that struct, right? So I got that. Now I want to do the checks. I want to print out my checks. So that would be CK1 and CK2, right? And then, I want to look at some different, I don't want to just go back through the same quadratic every time. I know from the discriminant, if I increase B, I'm going to get reval. I already know these are real X values, right? So if I have B squared minus 4AC, if I keep the discriminant positive, then I'm going to get real values. So I think what I'll do is I'll just say B equals B plus 1, right? And then that should, the next iteration through, then that should give me a very nice thorough example of running through some different quadratics. And to be honest, I may just print the B value here too. Why not? I know the A is going to be 1 and the C is going to be 2. That's static. So I could print the B like that. Right? And then to make everything kind of lined up, I could do something like that. All right, do I have a chance? We'll see what kind of problems we have. And then I put the end, so that end goes with the 4. So I should run this for loop 10 times. I clear the command window, clear the workspace, and then I do that. So I'm going to save it. So script 1 is over here. So if I type script 1 here, that should do it. Let's see what happens. Oh, cool. So I can scroll back up to the top. And you see I cleared the workspace. I cleared the command window, so it started with that header. So each iteration of the for loop is bracketed by the header. I've got the I, 1, 2, 3, and then my B starts at 3, goes 4, 5, etc. My X's are changing. You see my check values start at perfect 0, 0. There I've got some fuzz. I've got no fuzz there, beg your pardon. Perfect 0, I've got fuzz there. And incrementing, still real X's, right? And then I go all the way to 10, I equal 10. And the 8 had fuzz for both X values. Well, that just about does it. We've gone through a bunch of stuff here, a lot of different functionality here that I've shown you for MATLAB, and tried to explain how we're going to use it in numerical methods. So hope you've enjoyed it. Please let me know if you have any questions.